Katie Strausser from Exobionics over in the East Bay. Want to thank her once again. This is maybe her 5th or 6th time she's been here. And if you know the traffic, you know it's not an easy thing to do. So let me try to read her bio. Katie holds a bachelor degree from Carnegie Mellon, master's and PhD from Berkeley. One of the 3 primary inventors of the EXO-1, an electromechanical lower extremity exoskeleton, and is currently the controls engineer. She works on algorithms and software and various research efforts focusing on the human-machine interface. And you know, this has been available for several years, and I hope Katie will tell us, you know, where it sits now in the commercial arena. So let's welcome Katie Strausser.
Speaker. Oh man. Okay. Excellent. Excellent. Great. Awesome. So my name, as Dave said, my name is Katie Strausser. I am a principal controls engineer at Exobionics, but I've been working on this exoskeleton and this exo for a number of years. So today I'm going to talk to you a bit about my story, where I came from, in case anyone is interested in taking my spot at this class in a few years, because the traffic is terrible. And then I'm going to talk a little bit about EXO, who we are, what we're doing now, and then get into the specifics of the device. If you have questions, raise your hand or just yell them out. If it gets too long, then we'll push them to the end and make sure that I get through most of my slides. So who am I? I started in the humblest of states, Texas, and left from there to go to a little cooler climate, Carnegie Mellon University, where I majored in mechanical engineering with minors in computer science and robotics. I had been interested in robotics, knew I wanted to pursue robotics as a career, but was really into wheeled robots. I really wanted to work on rovers. I wanted to go to space. Growing up in Texas, right next to Johnson Space Center, of course, I was like, NASA girl, yeah. And I actually was able to do some work in wheeled robots and stuff between undergrad and grad school. But I got to grad school at UC Berkeley and was offered the opportunity to work in Professor Kazerooni's lab on exoskeletons for people who had suffered strokes and spinal cord injury to help make their lives better. And space is cool, but helping my grandma seemed like a better deal. And I had lived with my grandma while I was in Pittsburgh for a summer. She had suffered a stroke a number of years prior, and I had seen directly the effects of maybe, you know, she could have gotten a little better with more rehab. Maybe we could do something with newer technology to help her live the life that she wanted to live. So I stopped working on wheels, went to feet, started working on exoskeleton robots. I'm passionate about what I do and was very, very excited when my advisor, Professor Kazerooni, had founded a company that was Berkeley Bionics, and I could continue working on this research as a full-time employee. At Berkeley Bionics, at some point in the past decade or so, changed its name. We're now Exobionics, which should encourage more of you Stanford people to come hang out with us. But we are still in the East Bay. We're still making exoskeletons, and I could not be more excited to work there and continue doing stuff that helps other people. It's a great job. So that's me. That's where I came from. That's my story. So who's EXO? Exobionics has been working on exoskeletons for about 10 or 12, maybe more years now, spin out of UC Berkeley. We have focused on improving human mobility, human strength, human endurance. But our goal is to work with the person. We take this approach that together with the intelligence and the perception and everything of the human, that we can actually help make them better through our devices. So we have a lower extremity exoskeleton that we've used, one application in medical, one in military. We started doing strength augmentation for the military because if anyone here has tried to get funding, military is a better start, then you go medical. And then we also, newer to our product portfolio, are working in the industrial application space. So we're working on the Exo Vest and our Zero-G arm, both to help workers. So these are the industrial applications. You can see on the, I guess that's the left, yeah. It's the same that way. I don't know why that was confusing. On the left is our Exo Vest. The Exo Vest is it's actually unpowered. It helps add some torque to your shoulders and helps support workers. Want everyone to pick up like something fairly light on your desk, water bottle, pen, anything. Now hold it out like this. Okay, now do that for a while. You can pretend to do a task, okay? You want to do this for 8 hours? Anyone? Anyone? No. So this is really pretty lame, right? Like, we are asking workers constantly to sit there with a screwdriver, anything, and assemble cars overhead or do something like this. This action for a few minutes is not that bad. A drill doesn't seem that heavy. When you do that for an 8-hour shift, you just can't move anymore. Your quality of life after work is affected. Your productivity during work is affected. You have injuries and back problems and shoulder strain and everything like that. Basically, no one's happy. So we developed this vest. It actually helps support the forearm, gives you some extra lift. It makes this job a lot easier. We've deployed this. We are in trials at Ford, at Boeing, just released a big story with them using our vest on their line, building your next 787 or whatever they're building now. So hopefully we'll be helping a lot more workers with tasks like that. On the right, you can kind of see this picture that I chopped it. But anyway, that guy is using this rivet buster. And this thing is like 50 pounds or something ridiculous. And they basically take it to the cement and it's got the like hydraulic hose. And they're trying to do that all day. And it's crazy. I don't know who thought that we should like hold this 50-pound thing that's pushing against cement and do work all day like that. It hurts your shoulders, it hurts your back, and the people can work for like 5 minutes, then they take a break, then come back to it. So we're using a Zero-G arm, which was originally developed by Equipoise, with some of our mounts, and allowing the user basically to maneuver this tool weightlessly. So we're still using the user's skill, their ability to figure out how to place the tool, how to use it, how to wield it. We're just taking the weight away from them and allowing them to maneuver much more easily. People have been using this out in construction projects and things like that, and have doubled or tripled their productivity of their workers, and the workers are a lot happier not to have to haul that. So it's saving companies money and improving these workers' quality of life, because they can go home, still play with their kids and lift their kids up because they haven't been messing with this giant rivet buster all day. So those are our two industrial applications right now. Of course, these are just a start of where a lot of these things could be used in this technology. So we're continuing to develop that. But I'm going to switch to medical focus now. Does anyone have any questions on industrial or this type of workplace? Yes. They are both passive. They're both spring powered. So neither one needs batteries, plugs in, anything like that. So fairly light, wearable, portable. Yep. Yes? I think the vest is like 7-ish pounds. don't hold me to that in the court of law, but like under 10, more than 5, somewhere in there. So yeah. The zero-G arm gets mounted either on a platform or a scaffolding, so that weight matters less, but it's heavier. There's one more hand. Yeah. Oh, okay, cool. Okay, so now I'm going to move on to our medical applications. So our medical product is this. It's the Exo GT. It's a wearable exoskeleton. We're not the only exoskeleton. We're not the only ones doing this. Frankly, because there's a lot of people who can benefit from this technology, and we should all work together and share what we can and make the best thing possible. So we've got Exo GT from Exo. We've got the ReWalk 6.0 from ReWalk Robotics. Indigo from Parker Hannifin. I believe ReWalk was probably the one at the VA, if you guys saw those. And then Rex from Rex Bionics is the one on the lower right with the really happy guy walking. And there are a number of other exoskeletons out there, and I don't want to, belittle the work of any other group. These are the ones that are FDA approved, so this made my list a lot shorter. But there are a number of groups worldwide, especially at universities, working on various exoskeletons, and they have been for years. Yes.
What does it mean to be FDA approved?
So in order to sell a medical device in the US, you need to have approval from the FDA. Depending upon the type of device, determines what class you are in, and that determines what you are required to do to prove safety or efficacy or how much you have to do. So if you have like a cane or crutches, that's one class of device, and usually for that you just have to show that your design process was sane and safe and that your manufacturing facility is up to spec and everything like that. Then you can sell the device. For exoskeletons and things like this, we're the next class up, so we do actually have to show all of those things, as well as that patients have actually used the device and not gotten hurt, and that they have had some benefit from it, and a variety of things like that. So it's a little more stringent of a process. Once you have that approval, then you get that approval for a diagnosis, and you can then sell and market for that diagnosis. So right now, Exo GT is cleared for both stroke and spinal cord. So if you look at any marketing material from Exo, it will be for stroke and spinal cord injury. There is such thing as off-label use. Everyone knows because you've all taken drugs for things that aren't labeled, but that's up to. Yes and no. Dave's asking the hard questions. So basically, an insurance company won't cover something that isn't FDA approved, but just because it's FDA approved doesn't mean that the insurance company will cover it. Insurance definitely wants to see that they're going to get some bang for their buck out of covering this. FDA just cares that you're not going to hurt anyone. So there's a bit of a difference. Yes? There was, so ReWalk was actually the predicate device. So ReWalk was the first to file with the FDA, so they're the new, so ReWalk has the like FDA line. There's no insurance code right now for exoskeletons. So it can be billed under gait training, but there's no specific exoskeleton line yet. There's opportunities for people, so, yes. Yes, so Exo, Rex are therapy, ReWalk has therapy and a home use approval, and I don't know about Indigo, but I'm sure their webpage would tell you. So yeah, ours is therapy use only, clinical use. About 5 years ago when I gave this presentation the first time, the FDA actually had us classified as exercise equipment. And this conversation didn't much matter because we were kind of down there with the treadmill and stuff like that. They then realized what Exos could do, and the insurance, wasn't going to cover just a treadmill type thing and stuff like that. So this conversation has gotten more complicated, but that's good, I think, for us. So, So these are existing devices. You can see a lot of similarities between these devices. They're all lower extremity. One of these things that is not like the other is really Rex, and it's not because they just have a person in their picture. Rex is the only device that doesn't use an assistive device such as crutches or a walker while using the device. It is fully self-stabilizing, but it's also a lot heavier and slower because of that. Yes? So EXO I know is around $150K. I don't know the others, honestly. Luckily I'm not in sales, so I don't have to know that. Insurance does not cover the cost, yeah. On a case-by-case basis, I know because some of the other devices have home use, they've kind of gone through a case-by-case basis to try to get coverage, and I'm not sure what their success rate has been. Yes? We do have devices at the VA, and they are, Palo Alto has a few of multiple brands, so, and I'm not sure what their procedure for who gets in, but they've got them, so, yeah. Yes?
If insurance doesn't cover them, who is using them? Because there's not necessarily that many people that can afford $100,000.
Right, so most of them are being used in the hospital, so in the rehab setting. For rehab, they can still charge for gait training, so they don't get the premium. Like, a lot of times if you have a device and that device is better, but it costs more, the insurance will kind of pay a premium on top of that to allow you to use that device. There's not that for EXOs right now, but they can still at least charge for the PT's time and gait training and stuff like that. So a lot of devices have been covered just in capital equipment for a budget for a hospital. A lot of it is increased referrals to that hospital because they have EXOs. Some of it is grant money. Some of it is donors. So, yeah. You are supporting yourself, but the EXO is supporting itself. So you can still, provided you can feel your legs, you can still feel, yeah, your weight transfers through. Yeah. So I am going to talk about EXO today. A lot of the things that I'm going to talk about with EXO GT, though, are really applicable to all of these devices, as well as all of the ones that I haven't shown pictures of. These exoskeletons are very similar. We think ours is the best, and I'll give you a few reasons why. But a lot of the design paradigms and stuff that go into this are the same across a lot of these technologies. As I already said, we are cleared for stroke and spinal cord injury. Does everyone know what stroke and spinal cord injury entail? Okay, excellent. Yes?
Spinal cord injuries break up by the severity, like if it's above a certain degree, then it's part of
Yes, so we're cleared for, that's a great question. We're cleared for paraplegic up to some level T something that I can't quite remember. It may actually be C7. No, that's too high. T something. Can't remember. Man, that's a, I'll look it up. Yes, so we do require some arm control for the cane, walker, or crutches. Likewise, with the stroke, we require one arm to be under the user's control for the most part. So hemiplegia, paraplegia, not quad. Yeah, unless you still have tricep. Yeah. That's a not cleared. Not cleared. Yeah. I'm not going to say I haven't seen it done, but not cleared. Yeah. Other people are definitely doing research and looking into other applications of our device and devices like it. Multiple sclerosis, traumatic brain injury, Parkinson's, there's a group doing research on post-organ transplant rehab. When you have an organ transplant, you're weak and tired and things like that, but it is, of course, in everyone's best interest to get up and walk and move and get your blood flowing, but you may not have the stamina or the strength to do that. So one group is actually looking at this as an application for helping with recovery for that. So there's definitely applications outside of these top two, but those are the ones that the majority of the research has been done on so far. So why walk in an exoskeleton? Gait training is important. If you're going to be able to regain the ability to walk, if you are post-stroke and you are trying to retrain those neural pathways on how to walk again, repetitive stepping is important. Repetitive load-bearing stepping is even more important. So you need to be able to load your feet and your arms, or not your arms, your feet and your legs, and get a feel for how that works. Your neural pathways then are magic as far as I'm concerned, but our brains really are magic, and you can start to relearn that gait. Those exact methodologies, how that's working, the exact right way to approach it, is definitely the subject of a lot of research right now, but we know that walking is good. We can provide varied assistance. Turns out that me just moving your leg a lot is good in some ways, but not as good as really challenging yourself and challenging those muscles to do as much as you can, right? Nobody goes to the weight room and picks up the 5-pound weight. It's like, oh yeah, totally building muscle. Like, yeah, at some point that's really good, right? But in order to really get the most out of your workout, you're going to push heavier and heavier weight until you're doing what you can and continuing to build that muscle. That's what we're trying to do with the exoskeleton with our variable assist. We also focus on balance training. To stand up and stand here in front of you, I have to be aware of where my balance point is. Post-stroke, a lot of people lose that ability to figure out where balance is. They're like over here and they're like, yeah, I'm totally balanced. And you're like, no, you're not. And they're like, yeah, I am. And it's just how the brain has been affected by that stroke or whatever injury there is. And so we have some modes in here that allow the therapist to focus and give feedback as to balance, practicing weight shift in order to begin to start walking, practicing squats to learn to build that muscle and also to build that balance and proprioception are all really important. So those are some functions of the EXO. There's also probably some long-term use benefits for this. I have question marks by all of these things. There's initial research that suggests that these things are true. We're still working on it to ensure that they are true. Yes?
Is Exobionics as a company publishing this research, or is it from maybe a Berkeley lab that's affiliated?
It's a combination. So EXO has sponsored some studies. I did a study with some home users and primarily found benefits in bowel and bladder function, but we also have hospitals throughout the globe who are doing research into specific things of interest to them or with grants. So they're looking at a lot of these other things. So bone density is incredibly important for people who have had a spinal cord injury. Fractures and risk of fractures is huge. So we're still trying to figure out exactly how to get that bone mineral density up. So EXO's walking is perhaps a pathway to that. Bowel and bladder function is actually one of the most expensive issues for people with a spinal cord injury. Bladder infection from sitting and things like that can cause you to go back into the hospital. That's not cool. Bowel function can take a lot of your time out of your day to make sure that you're following your bowel regimen and things like that. And so we've done some initial studies with some individuals, and everyone had different reactions to the device using it on a regular basis, but everybody pooped better. I wasn't allowed to use that as the title to my poster, but I wanted to. But bowel and bladder function are really, really important to your quality of life, and so improving that is key. Pain is something that's really prominent. For some users, they have a reduction of neuropathic pain. For some users, they do not at all. I have no idea. We're working on that. Someone will figure that out. Circulation. just moving and getting your legs moving is important. And then there's this emotional component too. There's an emotional component of feeling like you're progressing, coming into a hospital, walking and leaving walking, being able to look someone in the eye, to do some of the exercises you used to do. We've seen some people really respond to that and are more engaged in their therapy and things like that. So we think that there's some possible benefit there. Yes?
Do you have psychologists or similar clinician that works?
Sadly not at EXO, but there are some at some of the hospitals who are doing various research projects. Not right now, no, sadly, yes. So, yes?
Treating scenarios, is it important to tune parameters to the individual? What is this?
Yes, so the question is about tuning parameters to the user. There's a lot that's adjustable both in the software and in the physical device. And those do all have to be adjusted to the user. There's a lot of work done to make the robot smart so that it can adapt. There's a lot done to make the robot physically kind of forgiving so that it can adapt, so that people can use it quickly. But then there's definitely things where you want to adjust the parameters properly, and how you do that and stuff is part of our training for our physical therapists, and then hopefully eventually we'll add more smarts back to the robots.
What's the fault? Not everybody's the same size, so how does that work?
I'm gonna get there in like a few slides, so yes.
Just came to my mind, behind the way you develop your algorithms versus machine learning these days. As an approach
Yeah, yeah.
to control, because a lot of machine learning repetition. Is that something very interesting?
We've thought about machine learning. We definitely have not used machine learning at this point, but we haven't ruled it out.
Possible.
It's possible, and then there's just a consideration of a lot of times machine learning spits out really great algorithms and you're not sure where they came from, and proving safety in that case becomes very difficult. So, yes?
You're saying that patient feedback has shaped things over the time.
Patient feedback has been absolutely the most important thing that we have done, and I'll tell a brief story. At the when we had been working on this device for probably a year or two, we thought it was great. We're like, yeah, this device is going to be awesome. We'd been walking in it, we'd been testing it, it was going to be great. And my coworker was like, well, I've got a friend who's a para. We'll have him come in and test it out for us. He'll be like our first subject. And we're like, yeah, great, we're totally ready. So we're thinking that he's going to get up and we're going to be doing laps up and down the hallway and it's going to be great. We spent 2 days trying to get him to stand. We had not properly considered, we had failed very spectacularly per Adam Savage's explanation. We hadn't properly accommodated the fact that he was not going to assist at all with his lower extremity when standing up. We thought we'd been faking it. We had not been, apparently. And so we had to go back to the drawing board, do a lot of work with our bracing, with our support, make sure all that was fine, and bring him back later. And we did get standing. It did work out. But we brought individuals into our office to do testing for us early on. For those of you who know Fernanda, who I know comes to this class a lot, she was one of our early users and has given me more feedback than, and has really been influential in shaping our product. We also took the device to our first 10 centers and spent a week with them, using it with their patients, taking copious notes, and a lot of stuff has changed from that. And then the product has continued to evolve, both with feedback from our physical therapists and also the patient population using it. So, yes? So the therapists go through now a 3-day training, and the users usually get in, and in the first day they're averaging 300 to 500 steps. So the learning curve for the patient is much, much faster than the learning curve for the therapist, but they're both not terrible. So. Yes. We haven't done that. There are exoskeletons that NASA has that they've been working on with IHMC out of Florida. So some similar paradigms. Unfortunately, my goal to get back to working for NASA is still there, and we'll get there eventually. Yeah.
The tensions and the strength and everything, is that based on just trial and error, or do you have like a set measure you just
For EXO, we started with clinical gait data, so there is data taken on what users can do and then combined, or how we normally walk, so the torques, the angles, things like that. You add the weight of the device, you add the weight of the person, and then we did some math from there, and then, but there was some tuning based on how it felt, things like that, so. Cool, so now I'm going to talk about how we actually started designing this. So just somebody tell me what well, I think I'm even on my slide. What would you consider first if you were going to design this exoskeleton? Where would you start? AutoCAD? Okay. Anyone else? For therapy, for a rehab center, where would you start designing?
Hip and chest mount.
Okay, so how you're gonna attach stuff? Yeah.
Hold yourself up, even if the legs were stiff and straight.
Yeah, support.
And
Good.
look into anthropometrics to figure out where I'm going to size it to start off.
Sizes and shapes, good. Yeah, I would actually say AutoCAD's about the 10th step down the road. That's not where where we started and where I started was talking to people. Talking to the people who are going to use the device. What do they need? What were they looking for out of the device? Where does it need to support? Where can it support? I learned a lot about people who might use this device. There's colostomy bags, there's baclofen pumps, there's a variety of other medical things that we needed to be able to accommodate. So we had to take that into account when we were designing chest straps and things like that. We had to look at size. Who are we going to accommodate? This device fits 5'2" to about 6'4", up to 220 pounds. Unfortunately, there's some good human parameters data. Most of it's from the military. So you get to figure out what that means for your grandma, like sizing after that. So we really looked at, and then what would the therapist use? And what would patients get into? So therapists need to be able to set the device up quickly or else they're not going to use it. They need to understand what's happening. The patient needs to feel comfortable in it. They need to be able to get in and do what they want to do. They need to feel confident that they're not going to fall, things like that. And that goes into the bracing and that support and how everything works. What other features can you guys think of that might be important when designing an EXO? Yeah. Water resistance. Excellent. Water resistance is incredibly critical if you're going to send a device out into the community. If you're going to keep a device in the rehab center, you want to be resistant to mostly bodily fluids, but other than that, it's less of a concern, but it's definitely a concern if you're going to go out in the community, and an incredibly hard one to address, too. So, yeah. Excellent. So if it's too heavy, a therapist can't move it, or it's going to weigh the person down and they're not going to be able to balance or maneuver it. And if it's too loud, no one wants to be near it, right? So those are really important things that have nothing to do with the functionality of what it does, but everything to do with, is someone actually going to use this device? Yes?
So I recognized, and I have thought about that before, that many therapists also consider keep easy to clean.
Yeah, yeah. So
Sometimes they are still
yeah, we actually, anything approved by the FDA, all the soft goods actually have to be wipeable to some number of wipes with disinfectant, antibacterial things. So if you look at this, all of the straps are this wipeable material. All of the soft goods are replaceable. And we have people who have bandages or something, or people who have accidents. You're looking at, a cath that comes undone when you pull a strap across or something like that. You need to be able to clean the device if you're going to use it person to person. So it's incredibly important. Yes?
A kind of recording device that remembers all its steps and movements and stuff like that. So if somebody calls, you know where and that kind of thing.
You're adding to my sales team right now. So yes, we actually want to know what's happening with these devices, right? That's really important for us also as we're developing new devices. It's really important for us if something goes wrong, we need to be able to help our physical therapists figure out what's wrong. Helps us to provide faster customer service too. So all of the devices are actually equipped with a method to transmit all of their data back up to the cloud. We can pull that down. I can look at the data, troubleshoot an issue that a user might be having. Maybe a foot sensor is dead. Maybe they're just pushing the button at the wrong time. I can see all that, give them information back to customer service, and they can help address that either with the service tech or the user. We also have this interface portal called Pulse. And so Pulse allows the clinician or the therapist to go online and say, oh, look, you did 300 steps today, but last week you only did 200. So look at that improvement. That's really looking great. And we're actually working currently, most of my day today was spent developing a better interface for that. So we're going to continue making that better. Yeah.
Assuming it probably took a lot of time and research to just deeply understand human movements and human balancing from a kind of both mechanical and biological perspective. Because before you can assist human movement, you have to understand what the phases are and how horses balance, all of that.
Yeah. Luckily, a lot of people have done that work, which isn't, I've read papers and I hung out at physical therapy clinics a lot and watched what the therapists were doing and saw, what they were looking for in gait and things like that. But that's absolutely critical. And knowing, when is balance important? When is this motion important? How is the knee and the hip angle timed together? Steve Collins, who will be here next week, will talk. He does ankles. We ignore ankles. We're friends. It's cool. So Steve talks a lot about ankles and push-off and timing, and the biomechanics of ankles and push-off and timing are insane and intricate, and you have a lot of torque very quickly, and I won't steal all his thunder, but he's done an amazing job of recreating that through a bunch of work, both here and at Carnegie Mellon. And so using a lot of that experimentation and some of the methods that he's done, you can definitely do some really interesting work in terms of biomechanics. So he'll talk a lot more about that, I'm sure. So yeah, 2 weeks. Get ready. Come back. Yeah. Anyone else have anything else that we should consider with this device? Yeah. Cost. My boss says that's important. I should do that. Yeah.
Coolness factor.
The coolness factor. Yeah, it's actually really interesting. All of these exoskeletons are black and snazzy. Part of that's because it's easy to manufacture with plastics and stuff tend to come in black and then they all match and it looks cool. But there is something about the look of it. You don't want it to look intimidating. You want it to look somewhat inviting. You want it to look cool. You want it to look safe. I was designing as part of a grant an exoskeleton for kids. We made it red. I've seen 2 other exoskeletons for kids and they're all red. Apparently that's the kid color. I don't know why. Adults get black, children get red. But there is something about how it looks and how inviting it is and what that does for your customer. And yes, of course, cost is incredibly critical, especially without insurance coverage. making sure that people can afford these devices is absolutely critical.
Do you expect the cost to come down?
Yes, cost with volume will come down. Yes, there's some fixed costs just on some. So Adam Savage talked about tolerancing and knowing where you can skimp on tolerancing and where you can't. And unfortunately, a lot of these parts are high tolerance parts, and they need to be to work like they do. Some of those costs won't come down, but some of it does come down with volume. Electronics volume is great, and we've been doing a lot of work to use suppliers and materials and things like that. Also, 3D printing is awesome and becoming more and more capable and cheaper, and so as we incorporate more of that, we can bring costs down from that too. Yes?
How much do the clinics need to maintain the device? And if somebody falls over, what's going to break?
Yeah, so they are to wipe down the device every time they use it.
I don't
Oh,
know wiping it down, but I mean, if somebody is using it
Yeah.
and they fall, what can break? What does a
Yeah.
clinic have to worry about in terms of maintenance?
yeah, so it's mostly just if they fall, which we've got lots of handles to prevent that, so we have had very few falls. Usually what happens is this is actually a 3D printed cover and that breaks, and then we inspect the device and put a new one on. So all of the devices come with a service package. So we do most of the maintenance for them, if anything needs to be done. But it doesn't need its oil changed or anything like that. So it is a pretty low maintenance device. Soft goods are replaceable, and we just send those out. So, but I mean, we are still fairly, in the life cycle of this product. We've been shipping since 2012, but things have changed. Our reliability has gone up, but we do still have field service techs and stuff to go out and fix anything that does break, or they get sent back and we fix them. So, yeah. Okay. Oh, yes.
What kind of power supply does it have? Does it need to be plugged in, or is it battery?
Yeah, we have 2 lithium-ion batteries, and they are removable, and they get put on a dock, and they get shipped with 4 of them. You need 2 to run. They charge faster than they drain, so it all works out. That is key. That is key. Which the therapists are pretty good about. So yeah, battery powered. So I'm going to touch on a few things that I think are really important, and we've talked about some of them. So this is back to our size adjustment. Everybody's a different height. That's great. Makes pictures a lot easier, right? But we need to be able to adjust all the sizes. So we actually only have 3 adjustments that need to be done to fit all of our users. So there's a lower leg, upper leg, and then hip width. The reason why we only have 3 is because we want you to be able to do this quickly, or else you won't use the product, because you're going to spend 45 minutes of your hour-long session setting it up, and then what's the point? So we have 3 adjustments. We have upper leg, lower leg, and hip width. All of the adjustments are done with a torque wrench. So this is our torque wrench. If you've never used a torque wrench before, it's great. It says this one is 50 inch-pounds. That means that when you twist it, it will apply 50 inch-pounds, and then it will click, and it won't apply more than that. So you know you've got it tight, and you know you haven't over-tightened it. If anyone's ever adjusted their bicycle seat and gotten like 2 blocks away and hit a pothole, and you're suddenly like real low, it's annoying, and that's why we have tools like this to ensure that you get the proper torque on it. Also just makes the therapist really confident that what they've adjusted to is going to stay and it's not going to hurt their patient, things like that. The hip width allows the device to fit snugly and support the person without being too snug, so we can easily adjust to a bunch of people very quickly. Padding is incredibly important. So especially with somebody who has suffered a spinal cord injury who may not have sensation below their foot, below their level of injury, if we have any sort of issue where we're rubbing or chafing or anything, and we don't realize it, we can cause serious health issues. We can cause a pressure sore, and that is not good, and nobody wants that. So padding is really, really important. So we actually worked with a soft goods designer. We worked with a bunch of patients and a bunch of feedback from orthotists and physical therapists and all kinds of people who know these things, and designed our soft goods. And we haven't had injuries due to chafing or anything like that. So that's really important. But we did, at some point, we had to just start building. And at one point, I was like, we had these upper thigh straps. Like, man, this really isn't holding the person. Like, we really need something to push their legs up, like here. Like, what would hold your shin? A shin guard. So I went to like the sports store and bought 2 pair of Puma shin guards, and they lasted on our EXO for like a year. We like had the little Puma logo bolted on there. We've gotten better. They look better now. But at some point you have to just start trying things and see what works. But it's also really important to get a bunch of feedback from a bunch of different shapes and sizes of people that you're going to work with, because everything's going to fit a little differently. So our device actually comes with a full fit kit. So in that top right, you can see a number of the torso pads. So the torso pad goes across here and fits your stomach and holds the person in. So we have a variety of different sizes and shapes to hold different people so that everyone can fit in snugly and with as little fabric there as possible, because it gets hot, but we'll work on that. The straps and pads also can be interchanged depending upon the size of the person and stuff too.
Change shoe size? Because
No. Yeah. No, yeah, so we don't have powered ankles, so we get less push off than you or I do when we walk. So we have to compensate for some of the gait for our lack of push off, and Steve will tell you why that's a bad idea later, but we get away with it. But we don't actually adjust the foot size, which is fun when I have kids in there that have like clown shoes on, because these are one size. But it hasn't caused that much of a problem. We do have to compensate in the gait a little bit for it, so it just keeps it simpler at this point, but it's an often made request. So donning and doffing the device is really important. You have to be able to get into the device, and you have to be able to do that relatively quickly and incredibly safely. Okay, so for a variety of reasons, our hard parts of our straps are in front. Great, better for standing. Not great for sitting, right? Like, how am I going to get into this device? And how am I going to get into this device if I'm transferring from a wheelchair and I've got to get in here? Like, I can climb my way in, but somebody who's transferring from a wheelchair obviously isn't going to be able to do that. So we had to really think about that. So we actually have this Don-Doff lever. Oh, wow. I just hit a button. Sorry. I'll keep talking while I cause. So we have these Don-Doff levers which allow the device to be opened all the way out. So somebody in a chair can come up easily and transfer onto the surface. Without any issue, they can get close. They can use a transfer board, anything that they need to get in. Thank you, Dave.
So we're pretty much at the end of our class time here, but there's some more to tell. But if you really have to leave now, please do so. And if you can stay, we have a video of it in use, and you can also come up and check it out and ask Katie questions. So we'll give you a chance to leave.
I'll skip to the video of Fernanda. If you guys are going to leave, you can see it in action that way. And then I can...
What's the full video about?
It's Fernanda walking.
Just the whole hour?
Oh, it's probably the whole class.
It's queued up to a specific point.
No,
It's the rest of the class from,
got it.
2 years ago.
from 2 years ago. Yeah. So this is Fernanda. For those of you who don't know her, she uses a chair. She has a spinal cord injury. She's been involved in helping EXO for a number of years, and she'll talk about it.
As an incomplete person in my diagnosis, after So the language and interaction with reading. Last week when I was at the lab, the new software that I got to try was it will really tune in.
Don't let engineers deal with mics. It takes too long. Yeah.
Good. And 1, 2, 3. So, there. Points. As if I. Okay.
So now I'm going to go ahead, we're going to walk. As you can hear, every time we switch modes, there's an audio cue, which basically tells me, like, hey, the next time you hit a button, things are going to move, which is a great reminder for me, since of course I'm responsible for making sure that what? She doesn't fall, right? Okay. So we're going to walk today in a mode that we call first step. And this is what we would normally use with a new user. And that basically means that the physical therapist, which I am not, but I'm playing one on TV today, is able to basically guide the patient, the user, and say, okay, we're ready for a right step, we're ready for left step. And I'm going to push the button every time that that's the case. In our more advanced modes, which Fernanda usually uses, but the device isn't set up and I can set up, but we don't have time, then actually her position is going to guide that step, and it will take a step when she is in the correct position for the step.
Before you get touched, just by standing like this upright, it allows me to wiggle inside to place my body within the device. But a lot had to go through that to hold me up and still have this wiggle room, this aspect of it. So that small gesture and movement that I'm initiating is benefiting already because I'm having to use the hip, everything, my shoulders. I wouldn't be able to do this without standing up on Exo on my own. Okay. All right. Yeah.
So in this mode, I'm pushing a button. In Pro Step and Pro Step Plus, it's based on her body posture. So we basically, do I want to step now? No. Do I want to step now? No. Do I want to step now? Yes. We encoded that into the robot. Yeah, so where your stance leg is. That carpet in that room we were having a little trouble with, so it's also small. So.
It's all right. I sometimes wonder why I'm doing this, but I'm good. Okay?
You compare the learning process as involved as like learning to ski or snowboard or something?
For the user, no. It really just, it depends upon their balance awareness.
Is it one direction? Forward,
Yeah, you can pivot on your feet, but there's no rotation. Yeah.
So you can make a really large circle if you want.
Yeah, and on not carpet, you can actually turn pretty tight, but on carpet, it's a little harder. Yeah.
So there's only forward, no backward?
Only forward, yeah. We have backwards. We haven't had enough requests from the therapist to work on that, and the foot size would probably be more of an issue there. So, yeah.
How about the sit to stand? Is this you helping her or is this the...
No, the device is doing sit to stand. So it does sit to stand, squats, and then walking, and then we can do step in place and weight shift.
Asymmetrical, even though it's recovering, it's still not the same.
Mostly her, there's springs in the ankles, and then it's rigid sagittal plane, so, but she has to kind of keep her body kind of pretty close, and that's an important part of gait training, so we're working on that. Yeah.
How do you decide to make the balance component separate from the exoskeleton? Like, to have it fuse with the body?
Yeah, so it's really a question of complexity of the device. So it's actually your earlier answer, which is cost. In order to self-balance the device, we have a ton of torque and stuff at our ankles. Our ankles are really awesome. And they do a lot to help us balance. But to replace that with motors and things like that is difficult from just a hardware perspective and a controls perspective. Again, Steve will talk about it and his years of doing research on this. So adding another actuator, though, down here at the ankle means that you're swinging something heavier, which means that everything else has to be beefier, et cetera, et cetera. So we could get away without it. You lose some functionality. You lose some ability to do passive, user passive balance. You lose some toe clearance space and stuff like that. But it's a trade-off. It's a complexity trade-off. Yeah. Right now we have about 10. But we've had up to probably about 20 in various phases of the program. Yeah, it's been, yeah, the team has grown and shrunk and stuff over the years. We started with 3 of us, and then grew, so. Most of our controls is evolving at this point. Yeah, so we've been adding features more so than changing some of the fundamental stuff, but yeah.
Going forward, do you feel like you'll sense more from the patient and more responsive versus and go
Yeah. It's a good question. Yeah, we've done some stuff. We've been working with a few labs who are doing brain-machine interfacing, which is clearly the way down there of sensing from the patient, right? Taking commands directly from the brain. There's some great work being done down at UCLA with Professor Reggie Edgerton in rebuilding the spinal pathways post-injury. It's absolutely amazing. There's work in Ireland on brain-machine interfacing. There's work up in Washington on brain-machine interfacing, and other places too. So that's definitely an end goal somewhere. We're doing more of sensing position and stuff like that from the user at this point to get more feedback from them and input from them. How far we go and where that line goes, we don't know. Good. Yeah, our patients are all very different though too. So that's yeah. So yeah. Yeah. So we kind of have broken down into. So originally all we did was sit to stand, walk, stand to sit. So sit to stand. There's a few parameters, but mostly just sit to stand. While you're walking, you can initiate the steps in 3 ways. You can push, the therapist can push a button on the controller. The user can use their body position, both in a forward and lateral weight shift, and use that to trigger the step. Or they can actually start to initiate the step with their back leg if they have some strength, and then we'll help them through that. Those are step initiations. Assistance-wise, we can walk in full assistance where we're actually providing 100% of the work and we'll move them through the trajectory. We can do adaptive where the device is like, okay, you're doing this much, I'm just going to do a little more to help keep you on this path. We can do fixed assistance where we say, nope, no matter what you do, the device is only going to give you 40% and you better do the rest. Now, if you get stuck, we will kick in and help you because falling is bad and standing like a flamingo too long leads to falling. We don't allow you to do that. And then we also have free. So we can actually gravity compensate a leg and allow you to walk with some of the support from the EXO, but like support during stance, but none during swing or something. And we can adjust that to be low assistance or high, even up to high resistance and make it really a workout. That's walking. Then we also have this set of features called Pregate. And Pregate is what we use to Pregate because it helps get you ready to walk, but a lot of them are skills that you might use later. So weight shift is learning where that center point is and how you need to shift off that leg to be able to start stepping. Step in place allows the therapist to practice stepping in place. They do a lot of like toe touches and stuff forward and things like that. And then we allow squats too for that balance and strength. So, and that's Pregate. So those are all our modes, I think. Yeah.
What are the different sensors that you use to figure out what they're capable of or what they're measuring these patients?
So most of that is based on how well they're following a trajectory that we've defined. And so that really comes in with the angle measurements that they're able to hit with the current and torque that we're providing. Yeah. So I'm like way past my time, but I'm also happy to answer questions because traffic's real bad. So
I got the last question.
yes.
So you've been at this for quite a few years now. So what is the state of your company, your business plan, the market, things
Yeah.
like that? I mean, you're going to be around next year? Are you struggling or?
Our stock went up 10% today, so we're doing good. Yeah. The story from Boeing, and then we just partnered with a Chinese joint venture to start doing some manufacturing and marketing over in China, where there's a large stroke market. So both of those are really good, and our stock's up 10%. So we're continuing to improve the EXO GT. We're continuing to improve the vest. The vest is really at its infancy. We're in these pilot programs. Boeing would like to roll it out to their whole line, which would be great. And then we're getting more and more acceptance in the hospitals and more research. So insurance is obviously great. More adoption makes sales easier, makes costs go down. And then there's plenty of other devices that a lot of these technologies, so elder care, home health care, back injury is huge. Some of the stuff that we've learned from EXO Vest and Zero G and EXO, we hope to, eventually some point combine in some of these other fields where we can use our expertise to do that. But there's a lot of improvements we can make here to make it more functional and easier to use. So we're focused on some of
It's
those.
good to hear there's a high probability you'll be back next year.
I sure as heck hope so. Yeah.
Okay, let's give Katie our thanks. And you're welcome to come
Yeah, and
check it out.
show and tells here. The few that stay get to poke and